Space is like nowhere else. It's a vast, mysterious expanse that stretches beyond our wildest imaginations. Down here on Earth, we are used to gravity, air, and temperatures we can handle. We walk, run, and jump, all thanks to the force of gravity keeping us grounded. But space plays by different rules. In the zero-gravity environment of space, the simplest tasks become complex challenges. Up there, things can float, boil, or freeze in the blink of an eye. It's a wild ride. Imagine trying to drink water only to see it form floating droplets that drift away. Imagine yourself floating weightlessly, stars all around you. The sensation is unlike anything you can experience on Earth. That's what it's like in space, no up or down, just endless blackness dotted with incredible sights. The concept of direction loses its meaning, no up or down, just endless blackness dotted with incredible sights. The vastness of space can be both awe-inspiring and humbling. But space isn't just about pretty views, it's a giant laboratory where the laws of physics put on a show. Scientists conduct experiments that are impossible on Earth. It's a giant laboratory where the laws of physics put on a show. From studying the behavior of fluids to observing the growth of crystals, space offers a unique environment for scientific discovery. Let's see how different types of matter behave in this extraordinary place we call space. The absence of gravity allows us to explore the fundamental properties of matter in ways that are simply not possible on Earth. From the way flames burn to the way plants grow, space provides a unique perspective on the natural world. It's a place where the ordinary becomes extraordinary. So next time you look up at the night sky, remember that space is not just a distant, empty void. It's a different kind of place, full of wonders and possibilities waiting to be explored. We all know solids, rocks, phones, even our planet. These are the everyday objects we interact with, and they seem pretty straightforward. On Earth, solids are defined by their rigid structure and fixed shape. But what happens when we take these solids out of our familiar environment and into the vast expanse of space? In space, the behavior of solids can be quite different and sometimes even bizarre. The lack of gravity and the extreme conditions can make them act in ways that defy our usual understanding. Take asteroids, for example. These giant space rocks hurtle through the void, sometimes smashing into each other with tremendous force. Unlike the solid rocks on Earth, asteroids can be loosely held together by gravity, making them more like floating rubble piles than solid chunks of rock. Comets are another fascinating example. Often described as dirty snowballs, they are a mix of ice, dust, and rocky material. These icy bodies originate from the outer regions of our solar system, where temperatures are incredibly low. When comets get close to the sun, the heat causes the ice to sublimate, turning directly from a solid to a gas. This process creates the beautiful, glowing tails that we see streaking across the night sky. These tails can stretch for millions of kilometers, creating a spectacular display. Even though they are in the cold vacuum of space, these solid objects can change and move in ways we wouldn't expect on Earth. The extreme conditions of space challenge our understanding of what it means to be a solid. From the dynamic collisions of asteroids to the breathtaking transformation of comets, space reveals a whole new dimension to the behavior of solids. So next time you look up at the night sky, remember that the solids out there are not your average rocks and ice. They are cosmic wonders with stories to tell. Liquids in space are a sight to behold. Without gravity to pull them down, they form perfect spheres. Imagine a giant floating raindrop. That's what water looks like in space. Astronauts have to drink liquids through straws because pouring is impossible. It's like trying to pour juice from a bottle that's floating in midair. The lack of gravity makes liquids act in fascinating ways, reminding us that even the simplest things can behave differently in the cosmos. Section 4. Gases on the loose. From balloons to breathing. In this section we will explore the fascinating world of gases, how they behave differently in various environments, and their crucial role in our daily lives and in space exploration. Gases are all around us, even though we can't always see them. They are an invisible yet essential part of our world, influencing everything from the weather to the way we breathe. For instance, the gentle rustling of leaves in the wind or the steam rising from a hot cup of coffee are everyday reminders of the presence of gases. But in space, gases behave differently than they do on Earth. The absence of gravity and atmospheric pressure creates a unique environment where gases can move freely and expand without the constraints we experience on our planet. Imagine trying to blow up a balloon in space. On Earth, the air pressure inside the balloon is balanced by the atmospheric pressure outside. But in the vacuum of space, there's no external pressure to contain the air inside the balloon. It wouldn't work quite the same way. The balloon would keep expanding as the air inside pushes outward, with nothing to push back against it. Without air pressure to push back, the balloon would just keep expanding until it popped. This dramatic difference highlights how crucial atmospheric pressure is to the behavior of gases. Speaking of air, astronauts need special suits to breathe in space. These suits are marvels of engineering, designed to replicate the conditions of Earth's atmosphere. These suits act like mini-Earths, providing oxygen and pressure to keep them alive and well. They ensure that astronauts can breathe, move, and work comfortably in the harsh environment of space, where the absence of air and pressure would otherwise make survival impossible. Section 5. Extreme space, where matter gets weird. Space is full of extreme environments that can do crazy things to matter. Take black holes, for example. These cosmic monsters have such strong gravity that not even light can escape their pull. Then there are supernovae, the explosive deaths of massive stars. These events release incredible amounts of energy, forging new elements and scattering them across the universe. In these extreme places, the familiar states of matter can be stretched, squeezed, and transformed in ways that defy our everyday experiences. Section 6. Space, the final frontier of wonder. Space is full of surprises, constantly challenging our understanding of the universe. From floating liquids to exploding stars, the cosmos is a never-ending source of fascination and discovery. As we continue to explore the vast expanse of space, we are sure to encounter even more mind-boggling phenomena that will make us question everything we thought we knew about matter and the universe we call home.